Hello everybody and welcome to the first lesson in our unit on graphing trigonometric functions. Today we will be talking about graphing sine and cosine functions, and our objective is we will graph sine and cosine functions changing only the amplitude and the period. When we graph a new type of function, the best way to go about it is to create a table of values, plot those values into the coordinate plane, and see what we get. For our sine and cosine function, we will find 5 key points, and those 5 key points we will get from our unit circle. Remember the unit circle, and if we go around the unit circle, we had the measurements in terms of the circumference of that circle, and for our graphing purposes, we will only be concerned about the measurements in radians, not in degrees, because it's really radians that measures the distance more than how wide an angle opens. The circumference of our unit circle is 2 pi since the radius is 1. And when we start, we are at 0 pi. Then if we go up a quadrant, we're going to get to pi over 2. 1 quadrant more. Now we're halfway through the circumference. That is pi. And another quadrant would be 3 pi over 2. And when we're back to the beginning, then we have made a full circle, and that is 2 pi. And now let's remember what were the coordinates of all these points in our coordinate plane. This first point had the coordinates 1 and 0. The next point had the coordinates 0 and 1. At pi we have the coordinates negative 1 and 0. And at 3 pi over 2 we have the coordinates 0 and negative 1. And now we're ready to set up our table of values with the values for x and for the sine of x. Now remember, the sine of x was the y coordinate of each point. At x is equal to 0 pi, our y coordinate, and our sine is 0. At x is equal to pi over 2, the sine is 1. At x is equal to pi, the sine is 0 again. At x is equal to 3 pi over 2, the sine is negative 1. And when we are back to the beginning at 2 pi, the sine is 0. And now we can take those points and put them into the coordinate plane, but first we have to label our axes. And for labeling the axes, when we graph a trigonometric function, it has to be done a certain way, since our x values are most of the times values of pi, and I want you to do them the same way each time, except for rare exceptions, which I will point out to you. So the actual graphs that we create look different, and you can see the differences in those graphs. And here's how we're going to label our axes. For pi, we're going to use 4 boxes. So go 4 boxes to the right, and here we're going to have pi. 4 more boxes would then be 2 pi. 4 more would be 3 pi. And obviously to the left, 4 would be negative pi. To go up and down the y-axis, we're going to use 2 boxes for each unit. So up 2 is 1. Up another 2 is 2. Up another 2 is 3. And down the same thing, negative 1, negative 2, and negative 3. And now we're finally ready to plot our points. At 0 pi, the y-coordinate is 0. At 1/2 pi, which would be 2 boxes to the right, the y-coordinate is positive 1. At pi, it's 0 again. At 3 over 2 pi, it's down 1, negative 1. And at 2 pi, it's 0 again. And remember, if we now kept going, since we're now back to the beginning, now the next point would be up 1 again, then 0, then down 1. And also if we went backwards, it would be now down 1 and back to 0. Those are the points, but even though that looks like a zigzag, the actual sine curve is smooth. It's not a straight line between the points, and it's going to look like this. And going further than the points that we had in our table of values, I'm actually going to make it using a dashed line. And this is the graph of our parent sine function. The curve that spans the 5 values we found in our table of values I made as a solid line, and from then going onwards in both directions I used a dashed line, and in a short moment I will show you why I did that. So now let's look at domain and range of the sine curve. The domain continues onwards towards negative and positive infinity, so that means the domain is all real numbers. Now the range is different. The range, our highest value that we can see is positive 1, and our lowest is negative 1, and it just keeps going back to those values. So we need to use brackets here. Negative 1 is part of the range, and so is positive 1. So the range goes from negative 1 to positive 1. Now let's look at our cosine function. And the cosine function we're going to create the exact same way as we created the sine function, with the table of values. And those values we are again going to get from our unit circle. So let's go back and look at our unit circle. And now remember that the cosine values were the x-coordinates of each point. The x-coordinate of each point is the cosine values, and those are the ones we're now going to use for our table of values. The pi values are the same that we used before. So we had 0 pi, and at 0 pi the cosine is positive 1. Then we had pi over 2. At pi over 2 the cosine is 0. Then we are at pi, the cosine is negative 1. 3 pi over 2, the cosine is 0. And 2 pi, back to the beginning, the cosine is 1. Now let's label our x and y axes. The x-axis, every 4 boxes is pi. So 4 more is 2 pi, 4 more is 3 pi. To the left, 4 is negative pi. And up and down, 2 boxes is 1 unit. 1, 2, 3, negative 1, negative 2, and negative 3. Again, we're going to label our coordinate plane the same way every single time for every graph, so the actual graphs look different. If we modify the coordinate plane, then each graph may look the same, but if we keep the same scale, then we see the differences in the actual graphs. And now let's graph our points. At 0 we got a y-coordinate of 1, then pi over 2, which is 2 steps to the right, we got 0. Pi, we got negative 1, 3 pi over 2, 0, and 2 pi, we got positive 1. And now if we kept going, we get back to 0, back to negative 1, back to 0, and to the left, back to 0, back to negative 1. Just like the sine curve, the cosine is not a straight line that leads to a zigzag, but a curvy line, which is going to look like this. And again, I'm going to make the rest just as a dashed line. And here is our cosine curve. And now let's look for the domain and range for our cosine function. Similarly to our sine function, the domain is all real numbers because it continues towards negative and positive infinity without ending. And the range is also similar. The y values go from negative 1 to positive 1 and always go back and forth between those two values. So the range goes from -1 to +1. For both our sine and cosine function, we see that if we go beyond the part that we have graphed in a solid line, the pattern repeats the same way, and it keeps doing that over and over again without stopping. And that's why these functions are called periodic functions. A periodic function is a function that repeats, and one cycle of that is called a period. And now we know what that means for our picture. A period is going one full cycle back to the point that we have been at before, and that is the part that we drew in a solid line. That is one period. Same for the sine function, going from 0 to 2 pi is one period. So how do we write the standard form of a trig function? We write it using the same letters A, B, C, and D that we have used for other function families before. I'm going to write it down now for the sine function, but this standard form goes for all trigonometric functions. A times sine of bx minus c plus d. Those letters A, B, C, and D have the same meaning and the same impact on our function as they have in other function families, and it doesn't matter that we're writing them with capital letters now. That's only because we don't want to get confused with the letters of our trig function. A, and to be specific, the absolute value of A for sine and cosine functions is called the amplitude. And what that does is it changes the highs and lows of that function. Then we have the period that we just talked about. The period of sine and cosine functions is 2 pi divided by b. And we have something else, which is the quarter period. And the quarter period is relevant for us for graphing purposes because we put each one of our 5 key points at exactly one quarter period to the right of the previous one. So it's good to know that quarter period, and that is obviously whatever the period is divided by 4. And then of course we have C, which is our horizontal shift, and D, which is our vertical shift. Now for graphing sine and cosine functions, the most important thing is to remember our 5 key values and to put them in the right places in one period of that function. And in order to do that and remember which one goes where, we have a memory trick for sine. That memory trick is called O-holo. Now what does O-holo stand for? O-holo stands for O for 0. So we start at 0. The next point is going to be the highest one, H for high. Then we go back to 0, another O. Then we go to the lowest, L for low, and back to 0. 0, high, 0, low, 0. That's the pattern for the sine function. For the cosine function, you have seen that it looks a little different. For the cosine function, a memory trick is holo. And holo has an H at the beginning and at the end. We start with the high, then go to 0, then go to low, then go to 0, and back to high. O-holo for the sine and holo for the cosine. Remember those and they will make it much easier for you to graph sine and cosine functions. So much for now. And now go ahead and watch the second part of this tutorial where we'll show how to graph some examples.